Hey, welcome back. I'm Pat at Maendeleolab. For today's topic, we will monitor and measure network performance. Today is the day I'm putting on my SRE hat. And let me tell you just a little about SRE. SRE is basically is a concept, coming from Google. As you see it there, it's site reliability engineering. This as a network engineer is really helpful because it gives you the opportunity to stay on top, to be proactive, keep things reliable, making sure that your network infrastructure is well understood. It is always a good practice to measure everything, measure what the network is, what good looks like, and communicate that to your development community. Right, your developers, applications owners, they need to know how your network is performing. It's a very good way of managing an infrastructure. So today we're doing this and we have tasks. The tasks that we'll perform today will measure performance across the VPC peering connection. And this is the VPC peering connection here. And what we'll test is connectivity between public subnets in network, customer VPC number 1 and customer VPC number 2. So we'll measure this connection. We'll make sure that it can communicate. We'll also test some more things like ping, how many bytes we can send across, all those things. Second task, we'll measure internet access from private to private subnets, correct? And this is what I am talking about. We'll test this, that traffic initiated from this subnet can access the internet. Same thing here to the right, traffic initiated from this private subnet in customer VPC number 2 should be able to initiate traffic to the internet. The third task will measure inter-VPC communication via the network firewall and the transit gateway attachments. And the traffic scenario here is traffic leaving private subnets in customer VPC number 1. We'll go through the firewall, right? Transit gateway, next hop. Next hop is the network firewall. Then it gets inspected and then back to the transit gateway to this private subnet in customer VPC number 2 and vice versa. So this scenario will really test in traffic to the inspection VPC. Same thing here, this traffic here will be central egress traffic to the internet. And here, the last task that we'll perform, we will analyze network traffic using VPC Flow logs. Very nice tool. It just gives you a high level view of what's going on in terms of communication between source and destinations. We'll look into CloudWatch metrics. And again, a great tool that AWS makes available. And they have metrics and they mean something. Understanding them is really what helps you stay on top of things. And we will look into logs insights. It's an interesting tool. We'll look into that. And lastly, we'll talk about CloudTrail. So that's the list of tools that you can use for network troubleshooting. We'll be back here, and now let's go to the command line. So the command line, let me explain this. I'm first going to connect to the public instances. I've already connected to them. So I have 2 public instances here in customer VPC number 1, one in availability zone 1A and the other in 1B. Same thing here, availability zone 1A and the other in 1B. The one running in availability zone 1A will be my top left command line. The one running in customer VPC number 1, availability zone 2, will be right here, bottom left. And here to the right, it's going to be the instance running in availability zone 1A here in customer VPC number 2. And my bottom right will be the one running in B. So I'm going to bring them all up here. So here I have these 2. What I want to do is use Tcpdump in the background, right? I'll run this in the background. Let me make sure. Do that. I'm going to run that command in the background. Right, so that's set. So that's running in the background, and what this is doing is going to capture packet. Packet capture is a very powerful technique. This allows us, network engineers or anyone interested in forensic data. This is how you can see what traffic is running on the network in this particular device through this port. So in this particular instance, this server, I'm running a packet capture for anything coming in on port ETH0 from this host. And I'm writing this as a file rotation 5 times up to 10 megabytes. It's going to write it to this file named cop file. And it's going to rotate. Every time it reaches 10 megabytes, it's going to rotate to up to 5. Right? And it's just going to keep going in circles. Same thing here. And what I want to capture is the traffic going from this subnet to those subnets there. So here I'm using, so we're going to test the VPC peering, and again, the maximum byte size that you can transfer across this link is supposed to be 1500 MTU or 1500. Right now, I'll have it set to 1360, so we'll start there. We'll ping it. Right now, it's working. You know, you can see there, we're sending 1368 bytes, added 8 bytes on top. And I will perform the same here for the other instance running in availability zone 1B. So it looks like things are looking good. We're able to ping across. It's working. And now I want to increase it. I want to see if is it going to be fragmented or is it going to discard the packet? So I'm going to increase it to 1500 because it's going to add 8. So here we are, 1508 bytes. It's still working. Yeah, let's make it 15,000 bytes. That is still working. So for me, what I'm thinking here, what's happening, I think the packet's being fragmented, but that'd be something to see. I will definitely be able to pick that up from the packet capture. For now, it looks like across the VPC peering link, we can do more than 1500 bytes. And again, this is assuming that there's fragmentation happening there. So we've tested this. The very next thing I want to do now is let's try this. I'm gonna do the same in the reverse direction. So I'm here, I'm gonna ping in the reverse, it's working. Go down here, same thing. So this is looking good. We have just validated that traffic communication across this link, it's working. All the instances, zone 1A to zone 1A, is they're able to communicate something as B. Zone 1B to zone 1B in both VPC, they're able to communicate. So this is good. Now the very next test is the internet traffic. We're gonna, from this subnet, public instances, right? Those are Bastion host in its public subnet as a DMZ. A Bastion host is a concept where you have a server running on the public subnet that you can connect to using SSH, for example. Then from there, you can now connect to private instances. So we're now going to log into the private instances, and then we're going to test the internet. So let's do that. So what I'm doing here, I'm using the SSH agent. This is why I'm able to just use my user and IP and just connect to it. All right, so this is great. We connected to all 4 instances. And we have connected to 2 instances here in customer VPC number 1 and 2 other here. And now we're going to start testing traffic to the internet. All right, to test traffic to the internet, we'll run these commands, are pretty standard. We'll run it here. This one also looks like it has access to the internet, looks good. This is now customer VPC number 2 instance in availability zone 1A. So we here now. So far, so good over here. We have access to the internet. Now we testing over here. So that was also went well. No upgrades. But again, if you are new to the command line, Linux for network engineers is a must now in the times that we're in. And the reason is just we have a lot of tools, a lot of utilities available to you to do a lot of things. We've definitely validated testing traffic from the private subnet to the internet. It is working well here in customer VPC 1, same as customer VPC 2. Now, the very next test is to test traffic between VPCs. And this traffic pattern is next hop is the transit gateway. Transit gateway, next hop is the network firewall. Packets gets inspected and then back to the transit gateway and off to the destination, which is customer VPC number 2. And the return traffic is the same thing, same pattern, transit gateway, network firewall, inspection, transit gateway, up to the destination. So very simple scenario, it's central inspection traffic. Let's test that. Very first thing is test the throughput, the byte size, right? We've already tested here with the VPC Peering. It looks like we can do more than 1500 MTU, which is really the maximum allowed, I believe, in one flow. This is why I'm curious to look at the PCAP to see if it's being fragmented. Here with the transit gateway, the maximum byte size that you can send in one flow is 8,500 bytes. Anything over 8,500 byte gets dropped. There's no, it doesn't get fragmented, it just gets dropped. So we're going to test this right now using ping. And here we are, private 1A, private 1B, and customer VPC number 1. And we'll send traffic over to customer VPC number 2 on those private subnets. Right now, the size is going to be 8460 bytes. And it's working. We have 8468 bytes. Is adding more bytes, which makes sense to the IP header. So right now we're doing good. We're able to send this much. It's looking good. I'll do the same thing here in availability zone 1B. We send traffic to customer VPC number 2. It is pinging. It looks good. I'm gonna tick it up. 470. So far, we're looking good. If you see there, we really at the we're getting close, right? It's 8498 bytes. I'm gonna stop it again. Maybe add a couple more. Let's see if that. All right. So now we have 8,500 bytes. Still good. Nothing is broken. It's really good. It's working. Now I'm gonna go over that by 2. Let's see. So this is really true that 8,500 bytes is the maximum. Anything over that gets dropped. So good information. And right now it's not working. I'm gonna take it back down because we like it when it works, and it's working again. So this is a good test. We are staying with the testing going across the across the transit gateway network firewall to the VPC. I want to play with this a little bit more. But the first thing I want to do here is do something. Maybe it's your first time seeing it, or maybe you've seen this before. But this is a great tool to have in your tool bag. But what this module does is now it's turned this instance as a HTTP server. Now it's listening for TCP on port 8000. It's listening for HTTP traffic on port 8000 on this server right now. With that command, That's what happens. And here, same thing. I'm gonna make sure it is using this. This is good. I'm gonna come back over to customer VPC number one, right? Subnets, and I'm gonna now do something really cool here. First thing I want to use is the command telnet. Today is really used to probe a device to find out if the port, the TCP port is available. So it uses TCP, and you know, a way to work with this is, for example, I'm going to try to telnet to this instance to see if this port is available, that it's listening. And the way it works, you just telnet command, the host IP, and the port that you want to find out if it's available. There you go. It tells you right here, it's connected, right? So it got there. It is working. Same thing here. I need to do this. I'm going to send this in the background as well. Okay, great. That's working. So now I can capture packets. I can definitely collect some data from this measurement test that we're doing that I can review later. And again, this is a mindset, service reliability engineering. Very powerful concept. It's great. Measure everything. Well, now let me run the telnet command here as well. On the telnet to 10.9.62, and I want to test for 8,000. All right, it works. Connected. Next thing I want to play with, we're going to test MTR using TCP. MTR stands for night trace route. Very powerful. It's one of those tools you can use to detect packet loss on the network, and you know, those type of things. I like it. It's a tool that I think is useful. I don't expect to see much here. You see, you know, we're in the cloud. Some of the information related to AWS underlying infrastructure is abstract from the output, which makes sense. You know, I don't want to give out any internal information. This is why we see all this hop, skip, and then right to the destination. Right now, it's looking good. 0% loss. Number of packets sent, right? It's there. The last measurement of latency was 4.1. It's going to keep changing. And this is what's saying here is that these measurements, so here's the average. This is the average latency, right? Milliseconds. This is the best, and this is the worst. Means the worst measurement of latency that has been seen across this communication is 7. What I know with this measurement latency, as you can see right now, the average is 3.9. And what is that measurement? That measurement is basically the traffic between here, you know, to the transit gateway, to the network firewall, inspected, sent back to the transit gateway, then to the destination. That whole trip is taking an average of 3.9 milliseconds. You think about that, very powerful. So that's the round trip. I'm going to do the same thing for the other instance. That's our measurement. If something goes wrong, you know what to look for, because this is what good looks like. We're looking good there with MTR. I'm going to jump to the very next command. The next command, it's one of the ones I like. It's really a nice command. I'm using netcat, and with netcat, it's very simple. Same as telnet a little bit, but this one does use TCP and UDP, so we can use both. We're scanning this host on port 8000, and connection was succeeded because it was successful. A lot of time, TCP is always the protocol of choice because it is reliable. If you are familiar with it, you understand that TCP is reliable. It's a three-way handshake. The application from here through the transit gateway and network firewall can give right here for that specific port. And again, this is the data that you collect, save, because it will be useful. One last test. So here we are, same thing, it succeeded, it worked great. Now this is going to lead me to iPerf. This is where we're going to test the throughput. We're going to test traffic, the throughput, how much bandwidth can we send between here and there. And remember, we are using T2 macros. Those are very small instances. They have limitations on how much data they can transfer between two ends. So we'll connect here. So first thing I am going to do for iPerf 3, we have to, one end has to be a server, the other will be the client. So right now on the right side, we will set these up as server. I'm basically saying I'm going to answer as a server. At this point, I can make it any port. For example, I'll make this port 8080. So now it's listening on port 8080. And I will do the same thing here. This is also listening on port 88. And now, all right, so here we are. We're going to clear the command line. Clean it up. Parallel streams, up to 14 streams, intervals of 1 second, time, duration, 60 seconds, port 8080. And let's fire away. Here we go. Now the results are here, the sum. So that's what I pay attention to. So far, we're doing a gig. How cool is that? This is great. I'm going to do the same thing for the other instance. All right, same thing here. Looks like we doing good. Over 900 megabits per second. You can see the summary. This one ended. It's done 1 gig there. Sweet. Very, very powerful tooling. You know, if you can use this, you're definitely on a good track, because this is going to make your life easier. How you stay on top of all those things that you are putting and adding to your infrastructure. So we're looking good. We tested everything. I like the testing. I'm glad that everything worked out. Just quick recap. We validated traffic going across the public subnets between both VPCs. We tested traffic from the private subnet all the way out to the internet. That worked well. And we tested traffic between VPCs going through the Inspection VPC. So those tests worked well. I'm happy with the outcome. Don't be discouraged by not getting something to work. Stay on it. You're going to figure it out. Be hands-on. Be practical. I am going to sprint through this because of, sake of time. So let's start with VPC Flow logs. VPC Flow logs, it's a powerful, nice tool in a VPC. When you go under your VPC in the console, for example, I have network dev 1. I go over the flow logs. Oh, interesting enough, it looks like I only set this to accept. Usually I like to accept everything, but that's okay. So what you're seeing here is CloudWatch logs, right? Basically, I'm recording traffic. So meaning that I'm only capturing the data that's accepted. Well, truly, I should really also look at rejects, maybe, to see what's being rejected, because it helps. And usually it's really just best to just have all type captured, because you want to see traffic that is accepted and rejected. That way you can troubleshoot. And if I go over to your logs, I go here, you can see these are all the interfaces. This is everything inside this VPC using an interface. The data in and out of that interface that is accepted is sent here. So I'm gonna quickly go over it, just looking at some of the traffic. Yes, maybe I should. Well, look at this traffic, for example. This is the traffic going to VPC number 2. So this is the traffic going from here to there. So I'm looking at, picked an instance running in this subnet, and we're gonna see traffic going to it. You can filter on the IP address. We'll make it like 30 minutes, and you can see there are some traffic. And what's really cool, let me pick something coming from, all right, pick this traffic. So here, this is when it's responding. So let me take when traffic is actually coming in. So here you see traffic coming from VPC1. This is the instance, right? Which is really this instance right here. Sending traffic to the instance in customer VPC2. And this is an ICMP traffic. How do I know ICMP is protocol 0, echo, right? And you can see that traffic is accepted. I'm going to look for some TCP traffic. So let me close that. I'll go down here. And here it looks like it's a response. I'm looking for traffic. There we go. And here you see traffic coming from this instance. Is going to that instance. Traffic was sourced on this port, right? This port belongs to this instance, and destination is port 8000, remember? And this is the TCP protocol 6, right? And this is the number of packets, and this should be the number of bytes if I am correct. That's the way it works. So you can see that's there, and then you can see the response should come up the other way. I should see the response. There we go. And here's the response back, coming back from port 8000 to that port. And this is really a great way to measure, not really measure, but monitor what's going on at the VPC level with the traffic. So this is always a first stop. You can come here just to have an idea of what's going on, and then take actions from there. So this is VPC Flow logs. The next one to talk about, we'll just go back. CloudWatch metrics is real simple. It's come here. This is where you have all the metrics. So by default, AWS will have namespaces for services, and some services will have namespaces, and I believe some services may not, but always come here just to, the most popular services always have some metrics. For example, for us, in our case, we have metrics for the transit gateway, network firewall, EC2 instances, the NAT gateway as well. Very powerful. We can take a look to see what's happening. So per availability zone, you can see, actually I'm gonna fix this. All right, this is, you can see now I have two availability zone, 1A and 1B. And to quickly take a look, you have two type of engine with the network firewall, stateful and stateless. So I don't expect to see anything with stateful because we're using stateless, right? We controlling traffic in both directions. So let me see if I can just pick the stateless. Great. So now I filtered out the stateful because we are not using stateful rules. Well, we are using our stateless rules, and I'm just going down the list. Received packets was good. It had some data there. Nothing got dropped. Passed packets, you can see we have some passed is there. Great. And that was 1B, right? Availability zone 1B. So if I look at 1A, dropped, nothing dropped, passed, yeah, some traffic there, and we see, yes, some traffic. So this is looking good. We can see metrics. We can really drill into it. So we were looking at packet received, yes, max, good, 1 minute. All right, so that gives us data points for what the traffic looked like for a period of 1 minute. It's pretty good. But again, if you're into monitoring your network, these are tools that you can use to have an idea what's going on. You have this great concept called anomaly detection. Very powerful. You can set this up so that it's going to learn your environment, it's going to learn your data. And every time there's a deviation, like something changes, yes, you're going to see it. So really cool stuff, really cool stuff. It's a lot to remember, a lot to work with, but the key here is just understanding what they can do for you and use them as you need them and become familiar with it. Eventually, after a while, yes, you work on this enough, it becomes something that you know that you can use to solve problems. That's really what it comes down to. The network firewall. I'm going to move back to something else. So that was for CloudWatch. It's a lot more to do there. You can explore this on your own. I'm going to move on to Logs Insights. And I'm going to go over it very fast. I really hope not to spend too much time on it. But let's take a look at Logs Insight. Very powerful. I love it. Logs Insight gives you a graphical view with a lot more data. It uses the query language to get things. So this is what I do. If you are new or not familiar with the AWS console, it is one of the best, in my opinion, because just be curious. You got a lot of areas where you can get information, help. You can learn how to do this, right? It's right there. For me, is going to queries and looking at some of the samples. Okay, like for example, using VPC Flow logs, I can drill into that. I can find the top 15 packet transfers across hosts, right? This is how you can find your top talkers. You can come here to find out the top 10 byte transfers by source and destination. This is how you can find out what resources, who's talking a lot on my network, who's using a lot of the bandwidth, who's really doing a lot, who's active. This is how you do it. So you just open it up, make a copy of this, or you can just click apply, it gets applied. And you have to select which log you want to query on. For me, I am going to do like this one here. And then I'm going to run a query. And here's the data. It returned, it showed what's happening. And it shows you who's the top offenders, right? Who's talked, who's doing what. Somehow you have these two doing a lot more bytes transferred. So here's an IP address. It belongs to an interface. We need to find out is to go to EC2. You have to come down to EC2, right? We're in EC2 now. And you want to come down to network interfaces. The network interfaces, you definitely want to filter. It is the transit gateway attachment. All right, this is really cool. Transit gateway attachment. So this attachment, transit gateway, because remember you get a transit gateway interface in the subnets. So the transit gateway in this subnet, sending traffic. This destination happens to be an instance. And that's the one sending the most data. And guess what? We are looking at data inside network, customer VPC number 2. And if I go back to this interface, this belongs to customer VPC number 2. Transit gateway attachment. And how do I know this? Let's open this up. I'm going to open this up. This VPC. And here you are. Customer VPC number 2. It was just that easy to find out what it was. Just had to keep follow, know where to go. So this is the top offender. And again, get familiar with this. Hopefully that was helpful. You can come here, find some queries, syntax, use it. You can become familiar with it, measuring everything and using everything available. That was Logs Insight. I hope you liked it. The very last one, finally, is the CloudTrail. CloudTrail is very powerful. And CloudTrail is basically this. Everything you do in a cloud is an API call, application programming interface. And API, I can simply say, API is like a menu. You go to the restaurant, you have a menu, you want appetizer, you want XYZ. And when you instruct the waiter or waitress to provide that service, that meal that you're looking for, it's done. It's same thing with API. So we making calls, we say, look, we want to delete a firewall. Let me make a call. That's a delete firewall API call. I want to describe a firewall. Let me make that call. I want to create a route. I want to describe. I want to, whatever you're doing, those are instructions that you're sending to the AWS application or console, and it's going to perform those tasks. And this is what CloudTrail, and this is now giving you an event history to know who made the call, who did what on your infrastructure. Very powerful information. Something happened, something broke, something's not working. Did anyone make a change? Did anything happen? So here in my case, I'm using automation. From the username, I can find out what that username did, right? I can find out all the things that user did. There you go, it's right there. Impressive. And you can drill into these, which returns a JSON output. Just for security purpose, some information on there I didn't want to expose. So this is what it looks like when you drill into it. It returns this. It gives you everything: the version, the user identity, right? Who it was, the principal ID, the ARN, the account, the access key, the username. It goes on. What the source IP was that made that call. Everything is here. It's a package, it's a detail. And this is the power of measuring your network and also monitoring it the way it's supposed to be. So this was a lot. Hopefully I didn't lose anybody. Hopefully you stayed with me. If you're still with me, you have basically collected a good portion of information that you can build up on, because this is the real world. This is how, from a networking perspective, you can perform at the top. You can have confidence in what you're doing, is by having this type of information and taking actions against it, right? Making sure that you are learning this stuff, you are making the time to do and understand what this is happening, what's happening, to perform well and to be reliable. So hopefully this will inspire you to look into SRE, what they're about, what does it mean, how does it apply to what you do. Trust me, it applies to everything. You'll find a lot of ideas using this. We have validated this network that we had built in the previous 5 topics. We know we can communicate across the public subnet. We can get out to the internet, and we can communicate between VPCs through the network firewall. So in the future, we'll definitely go into expanding this network, building a multi-region design or infrastructure, and we also going to perform the same testing across regions. We get into that, we'll get into creating VPNs, we'll get into create different type of attachment to the transit gateway, like connect attachments, which uses a GRE tunnel. But from here, we can expand, we can grow, we can scale from this design. It becomes a plug and play network. We can add things to it, we can remove things from it. So hopefully this was fun. You enjoyed the tools that we used. You can take this list and you can really do your own research and try to use them. This is good for now. I am Pat. I'm Maendeleolab. Really appreciate the support. And until next time, just keep doing this, keep learning, keep researching, keep doing all the development work that you've been doing. Don't stop. The skies are not the limit.